Hello! In this video, we're going to talk about the second kind of merge conflict, which is when you have two different repositories that have a different history and are trying to merge. So not two different branches that we're trying to edit the same line in a file, but instead two different repositories that have diverging histories. And in order to get to that, we have to talk a little bit about the structure of a Git repo and remotes and a couple of other things like that. So to do this, I drew a couple of little pictures and I want to describe this. So in the past, before Git, what we generally had was something called a centralized version control system. And actually, this is before my time coding, which is not that long, but this is in the old days of the pre-2000s. And with a centralized version control history, basically you had a central repo or a central repository that was the owner of the history of every file. So it contained information about the versions of each different file. When someone wanted to go in and edit the history, what they would do is they would basically check out an individual file. They'd tell that central repository, hey, I'm editing this file. It would lock it for everybody else, so only one person could edit. When that person was done editing, they'd send it back. And this kept the history very clean because only one person could edit a file at any given time. But of course, that's inconvenient because then if somebody else needs to edit the same file, even if they're doing something totally different, they wouldn't be able to do it. They'd have to wait for their colleague to put that file back. And I might be getting some of the details wrong because, again, I never used any of these systems before. But what Git does is it doesn't have an idea of a central master repository. Instead, it has everybody keeping their own copy of the history. And when you want to try to come together, you have to resolve any potential conflicts. So this is what we call a distributed version control system. For Git, every individual version of a repository, every copy of a repository has the whole history and can change the history as they like, and you only run into problems when you try to connect them. So to show what this looks like, I'm going to dive in here to our example that we've had before. Let's see what that looks like. So this is the system that we've seen before. Hopefully it's familiar by now. We have a couple of terminals. We're going to run different commands in or edit files. We have our file system here with our text files and our script, and we have this graphical user interface of the Git repository. What I want to show here is I've actually created a couple of copies of this on my local system, including one I'm calling the remote. So this is a convention. Often the remote, which is just a Git copy of the Git repository in another location. Often people will use a code forge like GitHub or GitLab to do that, but I want to show you that this is on my local system. There's nothing special about a remote except that it's not on your system. And in fact, a remote can be on your system. So here, I'm actually in a parent directory now. If you look inside this, you can see I've got Git tutorial 1, which is the folder that we've been using in all the tutorials up until now. I've got this Git tutorial remote, which actually looks identical. So if I look at Git tutorial 1 here, you can see I've got basically what you see here in this file explorer. But if I do the same thing for the Git tutorial remote, it's exactly the same. And in fact, if I look at the in the graphical user interface, I've got them both open in tabs here. If we look at the remote version, again, it looks exactly the same in terms of the file history. The main difference is that over here you can see now I've got my main branch as well as origin main. So origin is just a convention that we often use for a remote. And if I go here into my Git tutorial 1 and I ask Git remote, you can see I've got origin there. If I ask where that is, get URL origin. No, it's Git remote get URL origin. I gotta spell it right. Origin. You can see here that the URL is just a file system on my computer. Oftentimes, if you're doing this in a real system, you'd have like a Git repository up on GitHub as your remote. But here you can see this is just my local copy. This is the URL. And I've also made another clone. So if you look here in Git tutorial 2, actually let me do this down here, cd Git tutorial 2. here, git remote, get URL origin, it also points to this remote. But now these are separate repositories. These are all separate spaces on my local system. Okay, so what I want to show you now is what this looks like. Imagine that this Git tutorials remote was a GitHub repository, and nothing special about it. It's just hosted on a website, and I have now my tutorial 1 and tutorial 2 are just two different users that are doing something separate. So imagine now that I'm Git tutorial 1, user 1, and I just say, all right, I want to make a change. Git tutorial 1. I'm going to open up my text editor again, and I'm going to come into the README, and I'm going to say lots of files. I don't care about listing each individual one, and I'm going to do that. Okay, and then I'm going to come up here. You can see I've got uncommitted changes here, and I'm going to go ahead and say git add README, git commit don't list files. Okay, and then come down here and queue. Now, so that's user 1. Now imagine I'm user 2, and I make a different change. So I'm going to say cd git tutorial 2. I'm going to make a different change. So I'm going to change a completely different file. Let's say this user is coming in here, and we want to add a thing here at the end that says I'm done. So once this step is done, I'm going to say finished. Okay. So let's check up here. See, so this is in user 1. If I run script py, you see I have those things. That's the edits we made last time. If I'm user 2, now I've changed this script to now, oops, I'm using Julia syntax there. Python is just print. So let's do this. And so now you see I print out the lines of the file and then finished. Okay, so I'm user 2. I'm going to go ahead and git commit, git add script.py, git commit print that we've finished. Okay, so if you'll recall, in the last tutorial, we made two different edits on two different branches, and we only had a conflict when we tried to make changes to the same line of the same file, because Git knows line by line what's going on. And if as long as we're editing different files or even different lines of the same file, we won't have a merge conflict. Git will understand how to combine those. But in this case, we've done something a little different. So here you can see in Git tutorial 1, I've made these changes. Let me refresh here. Okay, don't list the files. So this commit here, 8d blah, 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 don't list files, points to this previous commit here, A3224A1, that's currently on the main branch, okay? But in here, as user 2, I made a commit that points to the exact same place that's actually different. So what I'm going to do to show that is here, you can see on my Git tutorial, if I say git status now, you can see here, this says I'm ahead of origin main, this remote, by 1 commit. So Git knows that on this local version, in tutorial 2, I have a change that isn't present on the commit. So what I'm going to do is I'm going to say git push. And what this says is it says, take my current branch, the changes that I've made, and push it to the remote. Okay, so now we've pushed the commit that I just made as user 2 in my local repository. I've pushed that to my remote repository, which again is just another system. So now if I look up here in my GUI, if I look here, you'll see now I have a different commit, 64AC, that also points back to A3224A1, where I've changed this line in the Python repo. So now my remote and my tutorial 1 have different histories, right? We have everything up until this commit was the same, but now we've got a different thing pointing back to that commit. So now, if I try to merge from one to the other, Git's going to complain that we have diverging histories. Okay, so for example, if I come here, let's close out of here. Let's go back to my Git tutorial 1. Git tutorial 1. If I say git pull, what that's trying to do is it's trying to merge the remote to my local system. If I say git pull, then you'll see a bunch of errors. So let me make this big, and we can see what's going on here. It says git pull, I might not have set this before, origin main. Okay, oh, here we go. So now you can see I have divergent branches and need to specify how to reconcile them, and they give us a bunch of options. Okay, so what this is saying is I've tried to merge from main, and I can't do it. So another way to show this, if you had tried to do git fetch, basically that pulls the information from the remote repo down to the bottom. What we can see here, if I come to Git tutorial 1, is that I have two different things going on. Let's refresh here. So what you can see here is that I've got, now I see origin main, the origin main branch, and my local main branch now have commits that are pointing to different places. And we need to figure out how to reconcile those. Okay, so this is the other kind of merge conflict. And of course, most of the time, you've got a bunch of other changes. You might have multiple commits that have diverged, and you have some conflict way back in the past, but it doesn't matter. Fundamentally, this is what's going on. We have Git trying to point two different commits back to the same commit, so we have what's called a divergent history. Okay, our histories are in conflict, and we need to reconcile those. So the easiest way to deal with this, from my perspective, is to as long as something didn't go wrong on the remote, if everything's okay on the remote, is to try to update your local copy to fix. So what I'm going to do now is I'm going to change my local branch, or my local repo. Instead of being on this main branch, I'm going to switch it to a new branch that I can hold on to, and then we can figure out how to merge. So I'm going to say git checkout -b. So what this does is it creates a new branch and checks it out. So that's what I'm editing. So I'll say git checkout b fixing. Okay, and then I'll go cd git checkout main. And at this point, my main and my fixing are the same. But what I'm going to do now is I'm going to tell my local copy that I want to make my main branch actually look like the remote branch. So I'm going to say git reset hard origin main. So what this is saying is I'm going to reject all the changes I currently have on my local branch, and I'm going to make my local main look like the remote main. Okay. So now you can see print that we finished 64AC38. That's the one that user 2 did, right? That's this version that is present at origin. So now if I refresh, what we'll see is my main branch will look exactly like my origin branch, and this commit will be my new fixing branch. Okay, so refresh. See, now our local main in green here is there, but we still have this commit that is now on a branch. So now we're in exactly the situation we were before, where we have a branch that we're on that is separate from our main branch, and we just need to merge. So this is pretty straightforward. We can say now git merge fixing. And we have to give it a commit message. And now we're all set. Refresh. So now we've merged that fixing branch back into the main branch. And obviously you'd want to add more descriptive commit messages if this is a real situation. But we've just taken our main branch locally that was in conflict. We've created a new branch, and then we've gone to merge. And if you've edited the same files, you have to deal with that, just like we did in the last video. But this is just to say that if things get out of whack, then you can still fix them. Git is designed to deal with merge conflicts. It's not that big a deal. Sometimes the remote is what's the problem. So if you screwed up and you pushed something to GitHub that you didn't mean to, and that's causing all kinds of histories, it can be a little bit more complicated. But fundamentally, the key things to keep in mind are, one, that there is nothing special about the GitHub version. of a repository and your local version. A Git repo is a Git repo. It's distributed. Everybody has a copy of a history. Sometimes those histories diverge and you got to fix it, but there's nothing special about what's on GitHub. So if you need to fix your main branch on GitHub, you might have to do some force pushes, etc. But you can get all of the information you need in your local repository. You can do the fixes you need locally, and then you can reconcile the remote with that without losing any work, without ever risking that you're going to delete files or destroy data. So I hope this was helpful. We'll get, in a later tutorial, we'll get into more complicated versions of this where you have additional files that you're not tracking that can cause a whole mess of issues. But fundamentally, it's important to keep in mind that your local repository is just as much a source of truth as a remote, and sometimes you've got to reconcile those histories, but you can do it, and it's going to be okay. So I'll see you in the next one.